Hi, this is Big Dogs Porton, and today we're getting ready to do, I guess, a part two on a video that we put up about this Anderson 3.5 inch power pipe. And we got a lot of skeptics, doubters about the flow that this 3.5 inch Anderson power pipe and can then filter flowed on our flow bench. It flowed 970 CFM. You guys can go back and look at the video to see it actually being flowed on the flow bench. And a lot of individuals, well, not a lot, but a few individuals got on our Facebook page and they questioned the validity and the concept of why we were doing this flow comparison, this flow test. Let me tell you guys, the flow test was done to educate. It wasn't done to bash Anderson or the power pipe. We recommend, we have recommended this 3.5 inch power pipe to many customers that falls within, the operating range and the horsepower range that this 3.5 inch power pipe support. And for some odd reason, whenever we, go against the grain, or whenever we, do flow tests on parts, popular parts, it seems like people get butthurt when they, see the results that may not be what they expected or may not be what they wanted to see. We'll just provide the data, guys. Okay, you guys don't have to take this, and get all butthurt and get upset because, you're surprised that these parts are flowing or not flowing the way that you thought or expected. We're trying to do things that most porters and most companies won't do. And that's give you guys the raw truth. The raw truth. Okay? Nothing else. Just the raw truth. That way you guys can go out there and you can pick parts, put together combos that's going to give you a higher percentage of success. We hear so many stories about guys spending all kinds of money, $2,000-$3,000 on cylinder heads and custom camshafts with, 620 thousandths of an inch lift to go on small motors. And these guys get them all together and, they spend months on forums and groups asking the question, well, what's wrong with my combo? How come my combo isn't making this power? How come it isn't making that power? And, they come to us and they ask the same thing, and we go through their combos and we see so many errors, so many things that people are not telling you. These guys that they're buying these parts from, they're not telling you this. One of the things that we do when you message us, we ask you, what do you want to do? What's your goals? What's your budget? And we recommend parts, typically camshafts, headers, cylinder heads, intake manifolds, and throttle bodies to get you to that point. And then we ask you about your supporting parts, your air filter, your intake pipe. If you're running a mass airflow sensor, what size is that? What kind of exhaust system do you have? What kind of mufflers do you have? Who's doing the tuning? These are the things that can make or break a combo. And when we ask you guys these questions, we're trying to help you guys. We're trying to help you. So apparently we had a couple of individuals get on our page when we posted the video of the Anderson 3.5 inch power pipe. And they didn't understand, I guess, what we were doing. I I don't know how, but I mean, we made it simple. You put the pipe on with a filter and you flow it. But I guess we need to get more into detail. So when Anderson advertised this pipe as a 3.5 inch, you guys have to understand one thing about this pipe. In any pipe, you have a 3.5 inch inner diameter and you have a 3.5 inch outer diameter. Now, a 3.5 inch inner diameter pipe is going to have more inside surface area than a 3.5 inch outer diameter. And it's, pretty much where you measure the pipe. This pipe is a 3.5 inch outer diameter. Actually, it's not even 3.5 inch. It's like 3.46 outer diameter. But I have the dial indicator set up. The inner diameter is 3.326. Okay? So it's actually not a 3.5 inch inner diameter pipe. That makes a difference on flow, guys. It's my fault. I thought you guys knew that. But that makes a difference in flow. Those few millimeters, that makes a difference in flow, surface area on the inside. So, yes, this is not a 3.5 inch inner diameter. It's 3.326 inner diameter. Okay? Now, what we're going to do, just to show you guys, this pipe flowed 970. You can look at the previous video. We're not going to flow it again because we already did it. We have one of our ported 75 millimeter throttle bodies. Okay? It's open. We have this screwdriver here to hold it open because our two springs isn't quite strong enough to overcome this spring. This has a dual spring on this throttle body. So this screwdriver is there to hold it. Hold it wide open. We're going to flow this throttle body with the radius. So you can see this particular throttle body CFM flow. Then we're going to leave this throttle body hooked up. We're not going to unbolt it. We're not going to take anything loose. We're going to then bolt this Anderson 3.5 inch power pipe up with this filter that we've already flowed. And we're going to see if the throttle body with the Anderson flows the same as the throttle body with just a radius. That way you guys can understand what the first video about this power pipe was all about. Now, don't get me wrong. 970 CFM on the intake pipe is a lot. It's a lot. It's much more than a factory setup on the Fox bodies, which flows something like 478, 500 CFM. Okay? The BBK intake pipe, we did a video on that. Actually, we did a post on it. That one flowed with the K&N filter. Actually, that one flowed. We flowed that one with our 9-inch high flow filter that flows more than this K&N. The BBK with that flowed 700 CFM. So it flowed less. Still more than stock, but less than even our ported 65 millimeter throttle body. Okay? All of that makes a difference once your motor horsepower, levels get to the point where it needs as much air intake CFM as possible to keep making horsepower on the upper RPM. Okay? So we're going to go ahead, set the radius up on this, flow it, and then we're going to set up the power pipe on this throttle body and flow it again. Okay? So we have the throttle body with the radius bolted up. The flow been started. Let's see what this does with just the radius. 12 1220, 1224. And to make sure it's all tanked up. So about 1220. So we're going to bolt up the Anderson with the can-in filter, and then we're going to flow it again. Okay, so normally you would have with the power pipe, or with the guys running a mass airflow sensor, you would have a mass airflow sensor. Now, if you're running a 77, 80 millimeter mass airflow sensor, it's going to flow pretty well, especially, you know, a good aftermarket, Pro M, whatever. They're going to flow pretty well because the only thing they have in those mass airflow sensors is the element and the support for the element. But the mass airflow sensors, usually you're going to have like, you know, an 80 millimeter. They're going to flow pretty well. Okay, we flowed a couple of those. We've also modified the forward 80 millimeter mass airflow sensor to flow, you know, 1100 CFM. You can also get, you know, bigger mass airflow sensors also. But for most applications, you know, a good 80 is all you need. Once you start going, you know, above 80, you know, you're not looking to put that 3.5 inch power pipe on anyway. You're gonna have something like a 4-inch, and you know, once you reach a certain horsepower level, we recommend a 4-inch anyway, a 4-inch or a straight engine compartment 3.5 inch inner diameter pipe. That's going to get you over, you know, 1,000 CFM flow. That's going to put you around 1,100 CFM with a good 9-inch high flow cone filter. So we're going to go ahead and put the Anderson pipe on this throttle body that flowed, ported throttle body that flowed 1220. It's one of our ported 75 millimeter throttle body. And we're going to see what it does once we bolt that up. Now we're back here with the ported throttle body that you just saw flow 1220 CFM with the radius 75 millimeter. And now we have our can-in filter on the Anderson 3.5 inch outer diameter power pipe that we flowed by itself without the throttle body, just the pipe and the filter. It flowed 970. So now we have it bolted up. Now this setup simulates guys that are running aftermarket speed density on their Fox, or guys that have the factory speed density where you don't have the mass airflow sensor in the intake track. We just have the filter and the throttle body. Now, for guys running the mass airflow sensor, you can have the Pro M that has the mass airflow sensor and the filter combined right at the end, or you can have, you know, an inline filter. You can cut this in half and put it however you want it. But for this test purposes, we're doing it this way, so you can see. So we have the flow bench set up, ready to go. Let's see what the Anderson does to the flow of the ported 75 millimeter throttle body. 924, 20, about 927, 25. Yeah, about 927. 927. So guys are saying, well, how is that possible when you flow the Anderson and the filter by itself and it flowed 970? This is why we test everything. This is why we test everything. Because theory is one thing, but when you actually test it, it gives you the facts. Now, the reason why is because, this setup without the throttle body terminated right into the flow bench. Okay. It had nothing else, in the way. Now, if we take the same size pipe as the Anderson with the 3.3-inch inner diameter, and if we added a length, probably about 8 inches before it hits the throttle body, the flow is going to go up to about 965 with everything bolted on. And you're saying, well, how is that? It's the same size pipe. You're just adding a straight piece onto the Anderson. I'm going to tell you why. Because air doesn't move like you guys think it does. If you look at how water moves in a river or how water moves on a water slide, air moves in a similar fashion. Okay? The faster the airspeed, the more straight line it wants to move. Okay? When you are speeding up the air, anytime the air has to turn, it's going to create pressure, which is going to back up, the air that's following. So with this, you have several turns. Okay. And this one is pretty much almost a 90. The air is coming off of here very, very fast. But the throttle blade, while up in throttle, is sticking straight up. So the air, instead of coming off and having time to straighten out, is hitting this corner, which is creating friction. It's creating pressure. And that extra pressure reduces CFM. This is why we focus more on line of sight when we port, especially our intakes, because, the straighter the line, the higher the flow. Of course, you're going to have, cross-section area also, but you get the picture. So this is what this setup did. So now you see you have a 1220 CFM throttle body, which that throttle body can support a whole lot of power. And you put this 970 CFM Anderson power pipe, 3.5-inch outer diameter, with the Canyon high flow filter that flowed 1100 CFM by itself. So now you have 3 pieces, and the bottleneck is the pipe. Now, don't get me wrong, 920 CFM, 928 CFM, that's a lot of CFMs, better than stock. But for test purposes and for, the sake of this video, this is what I was saying in the first video. Okay. So you go buy our throttle body, right? And say, for instance, you got a 347 that can make 430 to the wheels, or a 363, great torque that can make 430 to the wheels. And you say, hey, big dogs, I need a ported 75 or a ported 80. The first thing I'm going to say is, what size intake pipe you're running? And you'll be surprised. A lot of guys would say, oh, I got a BBK cold air, I'm great. No, you're not. You're not great. You're not great. Because realistically, 970 CFM, or with this setup, 928 CFM, Our ported 65 millimeter throttle bodies with the radius flows that. So this is what we are saying. We want you guys to think about the total package. Guys are arguing with us about, the videos we put up in our testing, but you don't understand. We port and see thousands of parts. We're doing this every single day, 6 and 7 days a week. Right now, it's 12:30 at night. Everybody's gone. I'm the last one here doing this video for you guys. So we're doing this on a regular basis. We see parts that you guys, can only see in the magazines. We're flowing these parts. We're cutting them up. We're taking them apart. We're doing tests like this. Tests like this, we do this all the time with simple things. We may be curious. What does this flow when you put this together? The guys and myself, we'll put it together, they'll test it, and we'll come back, oh, well, this isn't right, or this flows well, or this doesn't flow well. We've put together stock intake systems for Nissans and Jaguars and BMWs just to see what they flow. That way we have concrete data like this. Now you guys know, so it doesn't make a difference how big of a throttle body you go, as long as it's flowing more than a pipe, because the motor is going to see 928 CFM. That's what the motor's going to see. Now, if you change this pipe to a 3.5-inch inner diameter or 4-inch power pipe, then you're going to be well over 1,000 CFM, but you still won't be 1220. The 4-inch will put you around there, as long as it doesn't have too many curves. The issue isn't so much the design of the pipe. Actually, it is. It's a combination of two things. The pipe